Okay guys, so this is the boiling or melting point of ionic compounds, and if you've not seen the metallic boiling and melting points, that's designed to be the first one. So watch metallic first and then come back and watch this again. So just like with metallic or any other type of bonding, it's the same framework to your answer, these 4 key points. So I'm just going to go through these again, just like I did for metallic. So ionic bonding forms giant ionic structures, or you could say giant ionic lattices, that would be fine. And again, this word giant is really important because they're really big. They can keep on getting bigger and growing. So what holds it together? Well, again, if I was to draw a diagram, 4x3 grid, don't do any more, otherwise you're just wasting your time. If, for example, I had NaCl, and that's the ionic compound I'm looking at, sodium's got 1 electron in its outer shell, so it will get a 1+ charge. Chlorine or chloride will need 1 electron to be happy, so we'll gain an electron, so we'll have a 1- charge. So inside here, I'm going to write my charges, and they alternate in this lattice formation. So a plus, a minus, a plus, a minus, minus, plus, minus, plus, plus, minus, plus, minus. Just be aware though, it's not always 1 plus and 1 minus. It depends on what you've got, what your ionic compound is. So if I had, for example, MgO, then I would have 2 plus, because magnesium has 2 electrons in its outer shell, so when it loses them it gets a 2+ charge. Oxygen needs 2 electrons, so it'll be 2-, and you'd need to write that in the diagram. So definitely things to think about there. Aluminium has a 3+ charge, so you need to put 3+ for the positive. So what do we actually have there then? We have these positive and these negative ions, so positive and negative. And opposites attract, so if a positive and a negative attract each other, we call that an electrostatic attraction. So they are going to be attracted. And just like with metals, the larger the charge, the stronger the electrostatic attraction. So magnesium oxide would have much stronger bonding than sodium chloride, because it's got a larger difference in the charge. So we have an electrostatic attraction between positive and negative ions. They are ions though, not atoms. Again, if you say the word atoms, no marks, because there isn't any atoms in ionic bonding, there's only ions, hence the name. We then need to think about how strong this force is. Well, this force is strong. Electrostatic forces tend to be strong. So how much energy will it take to break? Well, the stronger the force, the more energy it takes to break. So this will require a lot of energy to break. And that's your model answer. Okay?